All right, guys, so we're going to start off with number 1, and it says to replace the missing value with a greater than, less than, or equal to symbol. You really don't even need to do a whole lot of thinking, hopefully, because you should have noticed that the number on the left is a negative, while the number on the right is a positive. Well, no matter what they are, a positive is always bigger than a negative, so that means you should replace it with this symbol right here. 3/8 is larger than negative 5/8. For number 3, in order to better compare these, we need to turn the 5/6 into a decimal. So I'm going to do that over here out to the side using good old-fashioned long division. So 5 divided by 6. Hopefully this is coming back to us. You always do the numerator divided by the denominator. And 6 won't go into 5, so you've got to add a decimal and add a 0. So 6 goes into 50 8 times. 8 times 6 is 48. I've got a 2 remainder. I can't have a remainder when I'm turning stuff into a decimal, so I need to add another 0 and then drop it down to go with the 20. 6 goes into 20 3 times. 3 times 6 is 18. Oh, well, there's a remainder of 2 again. Okay, so I could just keep adding zeros and doing this over and over and over again, but I'm going to keep getting a 3 every single time, and it'll never have a remainder. So therefore, as a decimal, I'm going to turn this into, because remember you shoot the decimal like straight up from the original problem. I put it right here. Okay, so the decimal goes straight up because you line it up from the decimal in the original problem. So this is going to become 0.83, and that 3 is repeating over and over and over again. So now to compare them. Okay, the first digit is an 8 in each of those decimals, so we can't use that one to compare. So I'm going to go to the next number. So I've got a 3 compared to a 7. Well, 0.87 is larger than 0.83, so that means, again, we're going to put it in that direction. Finally, the last one in this particular section, again, I'm going to turn this into a decimal in order to be able to compare it to the other decimal. So I'm going to do long division again. 8 divided by 15. Obviously, 15 won't go into 8, so we've got to add a decimal and add a 0, just like we did before. So I'm just going to kind of guess and check over here. I'm going to take 15 times maybe 8 as a good guess. Nope, that's way too big. Okay, can't do 15 times 8. Let's try, that's way too big. So let's do 15 times 5. 5, 25. Yep, there we go. So 15 goes into 80 5 times. 5 times 15 is 75. I've got a remainder of 5. I'm going to add a 0 and bring it down here. I'm going to get this out of the way. I know that 15 will go into 53 times because 3 times 15 is 45. I've got another remainder of 5. So you see what's happening. That's going to keep happening over and over and over again. I'll keep getting the same remainder of 5, which means that this time, and I'm going to shoot the decimal straight up there. So this is a 0.53 repeating, which means it's exactly the same thing as this 0.53 repeating. So I need to replace the middle here with an equal sign. In order to compare these and make them least to greatest, I am going to convert the 3 1/6 and the 3 3/4 into decimals. Right now, I'm going to take the 3.8. I'm just going to write it over here to the side. I'm going to write the 3.06 and just kind of write it over there to the side for right now. Now this 3 1/6, just like I did before, I need to do long division to turn that 1/6 into a decimal. Obviously, 6 won't go into 1, or the whole number, so I add a 0 along with a decimal. 6 goes into 10 one time. 1 times 6 is 6. I've got a 4 remainder, so I need to add another 0. 6 goes into 40 6 times. 6 times 6 is 36. Oh, there's my remainder of 4 again, so that's going to keep repeating over and over and over again. So that 3 1/6 is actually 3.16 repeating. That's not always going to happen, by the way, that the fraction just happens to match up with the 0.16 repeating. That was just a coincidence. Okay, I'm going to get this out of the way. And then we better know 3/4. 3 divided by 4 is 0.75. So that one is 3.75. So now, if we're putting these in order from least to greatest, they all have a whole number of 3, so that doesn't help me. So what I need to do is I need to look at the second digit, which is the tenths place. And because it says to put it in order from least to greatest, the smallest one, sorry. Oh, I just realized earlier that should have been a 3.06, not a 3.08. Sorry about that, guys. Okay, so the smallest one is the 3.06. Then the next smallest one is the 3.16, but we're going to write it in the original form, which was 3 1/6. Then the next smallest one is one that has a 7 in that, so that's 3 3/4. And last but not least is the 3.8. Okay, next up, we need to get these all into decimals again so that we can compare them. And I'm going to show you a little bit of a shortcut. Whenever you have a fraction that has a 9 in the denominator, it's the numerator, it becomes a repeating decimal. So instead of a -1/9, this becomes a -0.1 repeating. And again, that is whenever you have a 9 in the denominator. Okay, so it's -0.1 with a repeating bar over it. This 0.11 is already 0.11, of course. And then we still have just the -0.5. And then hopefully we remember that 1/10 is simply going to be a 0.1. Okay, 1 in the tenths place. So if I'm looking here, obviously the two smallest numbers are going to be the two negative numbers. Now, a lot of people would say the smallest one will be -0.1 repeating. Actually, I'm going to write this in red because, as you guys know from class, I write things in red when I'm making a mistake. So a lot of people would say -0.1 repeating is the smallest, and the -0.5 is the next smallest. But that is actually not the case because we're dealing with negative numbers. Okay, so the one that's actually the smallest is the one that is even more negative. -0.5 is smaller than a -0.1. So if I'm writing these in order from least to greatest, the smallest one is actually going to be -0.5. Then the next smallest is going to be the -0.1 repeating, followed by the next smallest, which will be 0.1, or 1/10, I'm sorry, in its original format. And finally, you put that fraction back in there. And then finally, what did I leave off here? Sorry guys, brain cramp moment. Oh, 0.11. So your answer is right here. So the smallest one is the -1/2. Then the next smallest is -1/9, followed by 1/10, because that's only 0.1, followed by 0.11. Okay, for number 11, all we need to do is add these together because we do happen to have a common denominator this time. So you'll remember when you're adding fractions that have the same denominator, you simply keep the denominator. 2/5 plus 1/5 is 3/5. So that one was easy enough. Kind of the same thing for number 13. That one's going to be pretty easy as well because we also have a common denominator. 5/16 minus 4/16 is simply going to be 1/16. Next, I've got 2/3 plus 1/3, and again, they've got a common denominator, so all I have to do is add them together. That'll be 3/3, which actually simplifies to 1 whole, or just to 1. Make sure you simplify, don't just leave it as a 3/3. Next, 4/3 plus 4/3 is 8/3. 3 goes into 8 2 times, and then that'll leave 2/3 left over. I didn't necessarily say that you had to turn it back into a mixed number, but you could have if you wanted to. but I would accept either one of those answers. Now finally with number 19, we get a little bit more complicated because we don't have a common denominator this time. So we need to look and see what it would be the least common multiple that 3 and 9 would share. Hopefully at home you're sitting there saying, oh yeah, it would be a 9. So I'm going to keep that 2 over 9 the same, and I'm going to multiply 3 times 3 and then 1 times 3 to turn that into a 3 over 9. So 3 over 9 minus 2 over 9 is equal to 1 over 9. Number 21, kind of the same deal. We don't have a common denominator again, so we need to get one there. So the smallest denominator that those two could have in common would be a 6. So I'm going to convert both of those into a 6. I would have to do 2 times 3 to get it to be a 6. So this becomes 3 over 6. And I would have to do 3 times 2 to get that one to become a 6. So this becomes 2 over 6. So 3 over 6 minus 2 over 6 becomes a 1 over 6. Number 23, the smallest denominator that 10 and 15 could both go into would be 30. So I'm going to do 10 times 3, of course, to get it to be a 30, which means 7 times 3 is 21. Because I'm going to do 15 times 2 to turn it into a 30, 2 times 2 gives me 4 over 30. So if I do 21 over 30 minus 4 over 30, that leaves me with 17 over 30. Okay, next up is number 25. The least common denominator that 20 and 5 will share is, of course, 20. So I already have a 20 for my 13 over 20, so I'm just going to leave that the same. Then to turn that 5 into a 20, I'm going to multiply it by 4, which means I'm going to multiply the 2 by 4. So that becomes an 8. So 13 over 20 minus 8 over 20 leaves me with 5 over 20, but I can simplify 5 over 20. We haven't had to simplify anything yet. So 5 over 20, because I can divide both the numerator and the denominator by 5. So 5 divided by 5 becomes 1, and 20 divided by 5 is 4. So my final answer is 1 over 4. Next, I've got decimals for number 27, and I notice that this is a negative and that is a negative. I'm adding two negatives together. So all I need to do, because they're decimals, is make sure I line up those decimals. So negative 32.4 plus negative 4.5. And because they're both negatives, I'm simply going to add them together. So this becomes 0.96 negative 36.9. Okay, with number 29, this is a minus, but please remember that negatives and subtraction really mean the same thing. So just like number 27, I'm really just adding two negatives together, even though this is in the form of a subtraction problem. So again, just like I did before, I'm going to line up the decimals. So negative 9 and 1600ths, and negative 10 and 1700ths, and then I'm just going to add them together. So 6 plus 7 is 13, carry my 1, 1, 1, 1 is 3, 9, 1, and they're both negatives. Again, I'm just adding those negatives together. So that is a negative 19.33. Okay, now with number 31, pay close attention to the fact that you have a negative and a subtraction symbol right here back to back. So remember that this really means that you're taking away a negative. Well, what happens when you take away a negative? It becomes a positive. So I'm actually just going to go ahead and rewrite this problem to reflect the fact that minus a negative 81.3 is really the same thing as adding a positive 81.3. So I'm going to add 72.5 to 81.3. Careful to line up those decimals like I know I should. So it's 8, 3, positive 153.8. For number 33, we're in the same boat that we were for number 32. Notice that we've got minus a negative, which means that that's actually going to be the same thing as adding a positive. So I'm going to rewrite the problem as 79.3 plus 14. Remember when there's no number there behind the decimal, there's really a 0. So I'm just going to treat it that way. So 0.3, 13, 7, 8, 9. I've got a positive 93.3 for number 33. For number 35, I have to get a common denominator for these two. The least common denominator would be a 6. So I've got a negative 1 over 6, because that 6 obviously is going to stay the same, minus. In order to get that 3 to become a 6, I needed to multiply it by 2. So 2 times 2 is 4. So now I've got a negative 1/6 minus 4/6. So remember, subtraction and a negative really means the same thing. So this is basically like I'm combining two negative fractions. Well, it's not basically, it is combining two negative fractions. So a negative 1/6 combined with a negative 4/6 is simply going to be a negative 5/6. For number 37 here, I don't have a common denominator again, so I need to change it to 1. The smallest denominator they'll both go into is 20. So I'm going to leave that 17 over 20, B, and I'm going to change that first fraction into a 20. So 5 times 4 is 20, which means that 2 times 4 is going to be 8. So I've got a negative 8 over 20. Plus a positive 17 over 20. So now, because they're a different sign, I need to use these 8 negatives to cancel out 8 of those positives. So when I do that, that's going to leave me with 11 over 20. And I have more positives than I do negatives, so it's going to stay a positive 11 over 20. Number 39, so we've got another example of where we're subtracting a negative number. Great, so we've got a minus a negative, which we will recall means that it's actually a positive. Okay, so, and I also need to get a common denominator. The smallest number that 12 and 4 will both go into is 12. So that negative 1 over 12 is going to stay the same. But I need to convert that 3/4 into something that has a 12 in the denominator. To get that 4 to become a 12, I would simply multiply it by 3, which means I'm going to multiply that 3 by 3. So that becomes 9 over 12. And remember that this is a minus a negative, which means I'm going to turn that into a plus. So a negative 1 over 12 plus a positive 9 over 12 means that this one negative is going to cancel out one of those positives and leave me with an 8 over 12. Hopefully we notice too that 8 over 12 is not simplified. I can divide 8 and 12 both by 4. So 8 divided by 4 is 2 and 12 divided by 4 is 3. So my final answer simplified is 2 over 3. Last but not least, we've got a word problem. So it says that 7/10 of the surface of the earth is covered by water, and then the rest of the surface is covered by land. So it asks, how much is covered by land? Well, if 7/10 of it is covered by water, then obviously a whole would be 10 over 10. That's the whole earth. So if you take the whole earth and you subtract the 7 out of 10 that is surrounded by or covered by water, that means that you're going to have 3/10 left over for land. So your final answer is 3 over 10.